Hey everyone, welcome to The Explainer. Today we are diving straight into a completely fascinating piece of research, the Zyphra 1-8b technical report. We're going to see exactly how a shockingly compact AI model manages to achieve giant-level reasoning capabilities. If you've been following the AI space lately, the race has largely been about building bigger and bigger models, right? But this report kind of flips that entire script completely on its head. We're going to look at the exact engineering, the training methods, and some really clever test-time compute tricks that allow a lightweight architecture to just punch way above its weight class.
So, let's kick things off with a pretty provocative question. How can a brand new, highly efficient model go toe-to-toe with the absolute behemoths of the AI world? Models like GPT-5 High, DeepSeek v3.2, or Gemini-2.5 Pro. They have astronomical parameter counts and literally require massive data centers to run, yet the authors of the Zyphra 1-8b report claim they're narrowing that gap. How is that even physically or computationally possible? What is the secret sauce bridging the chasm between lightweight efficiency and heavyweight performance?
Well, the answer actually starts with a surprisingly small number, 700 million. That is the active parameter count that makes Zyphra 1-8b the ultimate underdog. In an era where we casually throw around terms like hundreds of billions or even trillions of parameters, 700 million active parameters is incredibly lean. It means the computational footprint required to actually generate a response is drastically reduced. But hey, don't let that tiny number fool you. As we'll see, it leverages those 700 million parameters with absolutely staggering efficiency.
To understand this engineering marvel, we're going to quickly introduce the model, break down its small but mighty architecture, explore the 4-stage RL cascade, uncover its secret called Markovian RSA, and finally, look at some benchmarking against the giants.
All right, Section 1. Introducing Zyphra 1-8b.
So Zyphra 1-8b is explicitly designed as a reasoning-focused model, and it's built on Zyphra's MOE++ architecture. What's actually incredible here is that it matches or even exceeds DeepSeek R1-528 on several extremely challenging mathematics and coding benchmarks. And look, DeepSeek R1-528 is a highly respected model. To be matching it or staying that competitive with substantially larger open-weight reasoning models is just a massive testament to this team's focused approach to reasoning tasks.
Moving on to Section 2, Small but Mighty Architecture.
The absolutely crucial point here is understanding how it stays so compact. By using a mixture of experts, or MOE approach, Zyphra 8b actually has 8 billion parameters in total, but it only activates 700 million of them for any given task. It's kind of like a massive hospital filled with 8 billion specialists. When a patient walks in with a specific ailment, you don't need every single doctor in the building to consult, right? You only activate the exact 700 million specialists required for that specific problem. That architecture is exactly what keeps it so resource efficient while still maintaining this huge, broad base of knowledge.
And it's also vital to point out the hardware foundation. The researchers highlight that all of its core pretraining, mid-training, and supervised fine-tuning were performed completely from scratch on a fully unified, full-stack AMD compute platform. That includes AMD networking and their integrated software stack too. This is a big deal because it demonstrates not just the viability of the model itself, but the real maturity of alternative hardware ecosystems that are fully capable of training state-of-the-art AI right from the ground up.
Plus, because Zyphra 1-8b was built specifically for reasoning, the researchers didn't just wait until the end of training to teach it how to think. They integrated reasoning data right from the pre-training phase. They did this using a really clever method they call an answer-preserving trimming scheme. Essentially, what this does is it ensures that while the data is being cleaned and compressed to be super efficient, the core logical steps and the final correct answers are perfectly preserved. So they're essentially teaching it the architecture of logic from the very first pieces of data it ingests.
Okay, let's jump to Section 3, the 4-stage RL cascade.
This training montage is beautifully structured, walking the model through 4 distinct phases. Stage 1 is a reasoning warm-up focused on math and puzzles, basically just getting the mental gears turning. Then Stage 2 really ramps things up with an RLVE-Gym curriculum. This is essentially a massive, 400-task, rigorous workout environment to challenge the model across a bunch of different disciplines. Stage 3 zeroes in with targeted math and code reinforcement learning. Here, they actually use test-time compute traces and synthetic code environments built directly from competitive programming references. And finally, Stage 4 is behavioral RL. This polishes the model so it can handle your normal chat and actually follow user instructions. It really is a masterclass in progressive skill building.
Which brings us to Section 4, the secret Markovian RSA.
So let's break down that definition a bit.
Markovian RSA is a test-time compute method. I want you to think of it kind of like a relay race. Usually when models do complex, multi-step reasoning, they drag the entire heavy history of their previous thoughts forward into every single next step, and that eats up massive amounts of compute. But Markovian RSA recursively aggregates parallel reasoning traces, and this is the absolutely key phrase here. It carries forward only bounded-length reasoning tails between rounds. Basically, it drops all the unnecessary baggage and only passes the most recent relevant tail of the thought process to the next runner in the relay.
And by capping that past reasoning tail at exactly 4,000 tokens, the model saves an immense amount of energy. The researchers found that carrying forward just this 4K token tail is the absolute sweet spot. It gives the model just enough context to continue its complex logical deductions without getting totally bogged down by its own sprawling history. This drastic reduction in computational overhead at test time is the exact secret sauce that allows such a small model to perform deep, prolonged reasoning.
All right, final section, Section 5, benchmarking against the giants.
So when applying this Markovian RSA method, the test scores literally skyrocket. Zyphra-1.8b hits a staggering 91.9% on the AMI-25 benchmark, and over on HMMT-25, it reaches 89.6%. Guys, these are incredibly challenging, high-level math competitions. For a model with under 1 billion active parameters, to be scoring in the roughly 90th percentile on these modern, grueling reasoning evaluations, that is nothing short of a massive paradigm shift.
What you really should take away from this is that these elite scores mean this sub-1 billion active parameter model is successfully narrowing the gap with the massive industry giants. It's directly competitive with heavyweights like Gemini-2.5 Pro, DeepSeek v3.2, and yes, even GPT-5 High. The researchers have basically proven that you don't necessarily need the biggest model in the world to achieve top-tier reasoning. You just need a remarkably smart architecture, a rigorous training cascade, and incredibly efficient test-time compute methods.
Which leaves us with this final, genuinely thrilling thought for today's explainer. If such a small, efficient architecture can punch this far above its weight class today, using clever tricks like Markovian RSA and MOE to rival the giants, what new boundaries is this kind of extreme efficiency going to push tomorrow? Are we entering an era where hyper-capable reasoning AI can just run entirely on our local devices without needing a massive data center? Honestly, it certainly looks like we're heading exactly in that direction. Thank you so much for joining me to explore the fascinating Zy 1.8b report. Keep exploring, and I'll catch you in the next explainer.